Okie dokie, guys. Thank you for the very philosophical question about our philosophical conversation about our place in the universe. And now I'm going to answer a question that you guys probably have. Are we going to get started? Yes, we are. I know, it's mind-blowing. But anyway, today our topic is about counting. But instead of just talking about counting, we are talking about types of counting because we've talked about counting already. So, and today's lesson is going to be interesting because you guys are actually going to be trying to solve a mystery. So let's get started. Okay, Yolanda, you start.
Okay, so you are a secret agent in London trying to hunt down a mathematician turned assassin the only thing you know them as is Adder. That's the only thing you know about their identity. However, Adder has left behind a series of clues. He's a little bit sloppy, you see, and that can help us figure out his next target. So your goal is to solve those clues and protect his next victim. And of course, all of these clues are going to be mathematically inclined because Adder is a mathematician.
So if Adder is dumb, why haven't the police caught him yet?
Because the police don't know how to do math.
Yeah.
Emotional damage.
But you guys do. So we're going to help the police solve this case.
Yes. So the first thing is called casework counting.
So you're saying we're smarter than the police?
So the first thing is called, in this universe, yes. Well, I mean, you're a secret agent. You're like hired by the government, you know? So like, you're like special that way because like you're supposed to be smart. Agent. You're like hired by the government.
Wait, but then so, like,
you're like special that way because like you're supposed to be smarter than people.
Yeah, but then doesn't like the police consist of detectives? And detectives surely know how to do math.
They don't know how to do counting.
Imagine a Sherlock Holmes that does not know how to do math.
Okay, so to get started, there's this thing called casework counting, right? And this is just like introduce a little bit. So Adder has, since he's like a mathematician kind of assassin guy, he's kind of left behind like some math puzzle clues. And so you're gonna be like solving them. And luckily, your very good friend, Agent Yolanda, who is like your fellow secret agent, you know, she's actually kind of like found some of like Adder's clues and she's given to you. So yeah, and in fact, she actually figured one of the, well, I don't know who solved it. Maybe it's Yolanda, but like one of the clues has already been solved and Yolanda's gonna like explain to you how like this works.
Okay, so here's how I solved this clue, guys. So this, you can see this picture. The picture is the clue, and it's accompanied by this question, which is how many squares is in the picture shown? So, if you just like look at it really quick, you might think 2, but there's actually 3 squares, which I see like someone said in the chat. There's 3 squares, and we're not counting the big white outer square. We're like only looking at the stuff inside that. So yeah, there's 3 squares because the 2 larger squares overlap to form a smaller square in the middle. And I have to read off the slides because I have to follow exactly my script. Okay. So the answer to the first clue is 3. And now
write that down, guys. Write that down.
Write that down. Don't forget what the answer to clue 1 is, because you guys are going to have to solve the other clues and then put them together.
Wait, so why did Adder leave 3 squares behind?
I don't know. Maybe you guys will need to figure that out.
That's the first question we're going to ask him. Why did he leave 3 squares behind?
He left 2. They're overlapping.
That makes it 3.
Okay, so this is the second clue. So you can probably guess what the question is. So how many squares are in this picture? So I see a lot of you guys have put 5 in the chat, and 5 is correct. So obviously, again, if you look at it really like quickly, you might just think, oh, it's 1, 2, 3, 4 squares, but there's actually a big outer square that's like this. So that makes a 5th square. So in total, there are actually 5 squares in this picture. So write that down, guys. You need to remember these. So the answer to clue number 2 is 5.
Okay, and now for clue number 3. So this is actually the same picture as clue number 2, but there's another question attached to it. It says, how many squares or rectangles are in this picture? And okay, since squares are rectangles, just like count the number of rectangles. Just focus on the rectangles. And put your answer in the chat.
How many clues are there?
We don't know yet.
It-
Gotta find out.
If there's more than 10, he's a really sloppy man.
All right, we have a huge consensus on 9, and you guys are correct. So we have all 5 of the squares that we established last time, and then the ones that are just rectangles. We have like, yeah, Amy's gonna draw them. So we have 2 vertical rectangles and 2 horizontal rectangles. So that's 4 rectangles, and for a total of 9 squares or rectangles.
Write that down, guys. Okay, so the next clue. So this one, it looks kind of similar to the last one, but there's obviously difference. So there's this other thing in the middle here. So again, how many squares or rectangles, so basically rectangles, are in this picture? Yep, you guys got it. So in this picture, there are 18 squares or rectangles. And one way to do it is to actually look at the inner square and the outer square separately, because you might notice that like this inner square is actually just a copy of like the entire thing, just minus the inner square. So you have, here are the squares. So you have 1, 2, 3, 4, 5, 6, 7, 8, and then we've got 9, and then you've got 10. So 10 of those, and then you've got the rectangle. So 1, 2, 3, 4, and then 5, 6, 7, 8. So in total, there are 18. So good job, guys. And again, you got to write that down because this is going to be important soon. Oops, did you guys see that?
It says answer to clue 3 is 18, but before the answer to clue 3 was 9.
Where? Oh, oops, I was supposed to say clue 4. Whoopsie. 4. Sure. Good job. See, you guys are smart. You caught that mistake that clearly Adder made. Okay, so you guys probably saw the next slide. So good thing that you guys remembered the answer to each of the clues, because if you put them together, they make this sequence of numbers, and that actually corresponds to a warehouse address in London.
You totally love women. Totally.
Yeah. So
your neck is so long.
So now the very obvious next step is for you to, you know, rate the building, like check it out. And so this is a totally authentic photo of you.
It looks like a prison.
I mean, maybe it was, I don't know.
Is a prison?
I mean, maybe it is. You just have to go there and find out, you know? Okay.
All right. Don't worry, there's going to be more clues in the warehouse.
Yeah.
He's sloppy. He's sloppy. He's just really bad.
All right. Be on guard, agents. You stumble across a second set of clues, starting with clue number 1, set 2. So you can see the clue in the picture, and you decide to give it a try. The question asks, how many triangles are in the picture? So count and be careful. Don't mess up. There might be more than you think. And when you think you've got it, you can put your answer in the chat. All right, looks like we have a consensus on 17. So let's do this in kind of an organized way. Let's start off with the smallest squares. So we can see that there's like 12 of them. They're kind of grouped in sets of 4, and there's 3 groups. So there's 12 of those really small triangles. And now let's do the next step up, which is kind of the triangles that are the size of the 4 smallest triangles. And there's 4 of those triangles. Amy's drawing them right now. So that's 12 plus 4. And then we can't forget about that one biggest triangle surrounding everything. So we add one more, and that's 17, like you guys are saying.
Good job, guys. You solved the first clue.
So don't forget.
Write it down.
Yes, write it down, guys.
Exactly.
Okay, second clue. This one looks a little funky, but it's basically, again, how many triangles are in this picture? And be careful because sometimes it's easy to forget a triangle.
This reminds me of those ink blot tests because I see like an angel in that picture.
Oh, what do you guys see? I see like,
I see that radioactive symbol that they put on
yes,
those. I see
yes,
that.
that's what I see.
Oh, okay, that works. Or like mountains.
Or yeah, that works.
Yeah, same.
Okay, looks like we have a lot of people saying 8, and that is correct. So you guys solved clue number 2 correctly. So write it down while I explain this. So first there's like the big triangles, like the 4 triangles that are linked. So there's 1, 2, 3, and then 4 of those, right? And then you've got the smaller ones. So this one's kind of tricky. You just have to be super careful. So there's like this triangle up here, and there's this triangle here, and this triangle here. So that's another 3 triangles. And then you've got this tiny triangle in the middle that's like the overlap of all of the triangles. So together that makes 8. So good job.
All right, on to clue number 3. So now we have this interesting 6-sided star. It says last one, but it might not be actually the last one. How many triangles are in the picture? The trickiest of them all.
Factorial. Oh my gosh, that's a lot of triangles.
All right, so we've -3. Good job. That's impressive. If you get -3. All right, so it looks like we have mostly a consensus on 20. So let's go through it. And this one would be really helpful to use like kind of a organized way to go about it. So we can start from the smallest triangles, which are just like, one triangle. How many of those are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of those. And now let's go one step up, which would be the triangles that are kind of made of like 4 other triangles inside of them. And let's see, I can see 1, 2, 3, 4, 5, 6 of those. So like 3 of them are pointing up, 3 of them are pointing down. And now we can't forget about the last 2 triangles, which are the big ones, composed of like 9 of the smallest triangles. There's 1 going up and 1 going down. Or you, oh wait, are there 9 triangles? No, maybe not. Oh yeah, there are. Okay.
That just looks messy up there.
Yeah, so that's where these kinds of problems are easy to make like small mistakes. So check your work and try to stay organized as much as you can.
Yep.
Okay,
In
but
total, there's
overall, you guys did a really great job with these counting problems.
and write that clue down.
Yes, don't forget it.
Okay. So now, clue number 4. So basically, this is kind of weird, but you actually find a message decoder painted onto the wall of the warehouse, which is like really convenient, right? Because you don't want to pull out your own. But it's also kind of a little suspicious. So decode the message for us, okay? And this is like the decoder down here. And just write in the chat what it says.
Why would Adder help us decode his clues?
Probably because he's really nice.
Maybe he is really nice. He's
But
saving
isn't
us a lot of
it
work.
crime?
But he's an adder, and adders are really poisonous.
Yeah, an adder is a snake. So,
No, you guys can't. Oh wait, it says run. Run where? You're trapped in this warehouse.
yeah.
Outside the warehouse.
Dun dun dun. What happens next?
Yeah, so it looks like the message actually says run, which is kind of ominous. So actually, it turns out that the warehouse was a trap. So which is kind of a problem. So you've actually been ambushed by 5 very skilled ninjas, as you can see here. They have a bunch of weapons.
It's dabbing.
They just
So-
look like these little kids who got lost in their ninja outfits for Halloween.
There's one who doesn't have a weapon and is just dancing.
So yeah.
That's adorable. But anyway, there are 5 very scary ninjas, and you're very scared, so you got to use math to defeat them.
They're totally not kids. They're totally not kids.
They're very threatening.
Classic
They're
art.
adults. They're full-grown adults. They're just like really short. Unfortunately, you're not like a super like you're not like super good at martial arts. You're not like right. But
Wait,
you do know something.
wait.
called-
I thought they were. I thought we were specially trained agents, though.
Yeah.
How does
this
that
is
make
your
sense?
weakness. This is your like one weakness. You know, everybody has a
trained in math.
weakness.
The
Yeah,
why
you're
does-
trained in math.
Why does Britain's government have to have such low quality training?
It's not low quality. Okay, Amy's gonna explain how our math skills
No,
will allow us to defeat the ninjas.
yeah. So basically, this is really super skill called sticks and stones, and we're gonna explain to you guys how like your training works. So basically, sticks and stones. So let's use this example. Like pause for a moment, like going into flashback when you're actually like learning it. So basically, this is how sticks and stones work. Let's say you have like a bunch of like money, right? You have like 10 coins. And you've got like 4 friends, right? You obviously have more friends than that, but like these are the 4 like who like you want to split up this money between. So 10 coins, you want to split it up between 4 friends. So the way you can think about it is that you can like split the coins into 4 groups, right? So like you can say, okay, these will go to this person, and then like these will go to this person, and then like these will go to this person, and then like these will go to this person, right? So you can split them up in like that many like groups. And so one way you can, instead of like circling like 4 groups, what you could actually do is use like 3 like stick dividers. So like that way everything to the left of the first stick goes to like this person. Everything to the left of the second stick and in between to the right of that stick goes to like this person. And so like so on and so forth. Like everything in between, like you have all the 2 sticks goes to like a person. And then the last person is like everything to the right of the last stick. So why I'm introducing it like this is because you can actually assign it in any way with just like these 3 dividers, right? So like if you put the dividers in this position, then Yolanda's getting like 2 coins, Ruth is getting 3 coins, Angela doesn't get any coins, and Kayan gets like 5 coins. So yeah. Or you can even make it so that Yolanda gets all the coins. So like if you put all the dividers in like the far right corner, then there's no coins between those 2 dividers, which means that Ruth doesn't get any. There's no coins between these dividers, so Angela doesn't get any. And there's no coins between after the right one, so which means Kayan doesn't get any. So in this position, Yolanda gets all the coins.
Yay. Also, Amy, I think there's a bit
She's
of lag,
greedy.
because we couldn't see the visuals for like the other ones in the middle.
How do we know that
Oh.
Wanda is greedy? Couldn't everybody just be like super kind and give all the coins?
Well, this is just an example. Yolanda's not greedy in real life.
I am offended.
I knew that, but yeah.
So basically, notice basically the point of like this example was to show like the order that you arrange the sticks and coins in determines like who gets how many coins. So for example, in this position up here, if this is like Yolanda, this is Ruth, or sorry, oops, that's not right. In this position up here, Yolanda would get 0, Ruth would get 2, Angela would get 4, and then Kyle would get 4. So basically, all those arrangements of like coins, cough, like stones, and sticks, which are like sticks, that like determines who gets how much stuff. So if you want to find the total number of ways, like how many, basically the question is asking how many ways can you give like 10 coins to 4 friends? You can reword that to say the number of ways to give 10 coins to 4 people is the same thing as the number of ways to arrange the ordering of 3 sticks and 10 stones. And the reason why we're reordering it is because then you can use the thing that you learned a while ago. I don't know if you guys still remember, but it's called a combination to like actually solve for the total number of arrangements. Because remember, for a combination, you have like n things and you want to choose like X number of those things. Well, in this case, we have 13 object positions and we want to choose 3 out of those 13 positions to put the sticks in. And then we fill in the rest with coins because that's like the default. So the total number of arrangements would be 13 choose 3, which is a combination. So that'd be 13 times 12 times 11 divided by 3 times 2 times 1. So that's 286. So in other words, there are 286 ways for you to hand out your 10 coins to 4 friends. So does that make sense to you guys? And if anyone has questions, you should ask, because this is a little bit of a confusing topic. Like at first when I learned this, I was just like, why are you like putting sticks between like coins and stuff? Like,
All right, I have a mini quiz to test if you've been paying attention. So say we have 8 friends and we want to divide 10 coins among them. First of all, how many sticks would we have to use if we have 8 friends? 7. Yep, we would have to have 7 sticks to divide up the 8 friends. And then how many total objects would we have once we have those 7 sticks?
17.
Yep, so 10 coins plus 7 sticks is 17 total objects. So 17 like total positions for these objects exist. And then now we are going to use combinations. So we choose, since we can do 17, choose 7 because we're going to choose like where we're going to put the sticks. And the sticks are identical to each other, so this would be a combination because it doesn't matter like where you put each stick, or like swapping the sticks between each other.
And then that equals 19,448, which I don't expect you guys to calculate by hand because that's a big number. Okay. So now, how is this going to help us with your dilemma in the warehouse?
And flashback.
Yeah, end of flashback. Okay. Well, see, here's the thing. There's like a bunch of bricks laying around in the warehouse, right? So you're very the strategy that like the government taught you was to pick up those bricks and throw them at people. So that's the strategy.
That's an instinct. That's an instinct.
Yeah, I mean it's a pretty effective strategy, honestly. Like,
yeah, the Raj is right. At children,
they're not children. They're full-grown adults. They're murderers. So it's okay. This isn't self-defense. So yeah. So luckily you're really good at throwing bricks. So you scoop them up and you throw them at your 5 attackers, and all 6 of the bricks hit somebody, which is an ouch. So how many ways could this have happened? So in this case, there are like 6 bricks, and you can think of like you're giving 6 bricks to 5 attackers. More like throwing them. So
you're like giving them to them and begging them to throw them at me.
So use the sticks and stones strategy to figure out how many ways this could have happened. And if you don't remember, the sticks and stones strategy is like total number. You find the number of sticks needed. You need to know the number of sticks needed, and you need to know the total number of objects, like the stones plus sticks.
Then do a combination.
Since all the bricks hit somebody, we give bricks to each of them. And then you have 1 left. No, all the bricks hit somebody. Not everybody got hit by a brick. Like maybe all of the bricks hit 1 person.
Oh my god, 1 poor person. I mean, wait.
That'd be sad.
What if the brick
So
just
think about it like this. Every brick hit somebody, which means that like you have 0 bricks remaining that were not like thrown, but not everybody got hit by brick. So maybe all 6 of the bricks like hit 1 person, that 1 person's just like knocked out. Or maybe maybe it was like this, like maybe 1 person didn't get hit by any bricks, one person got hit by 2 bricks, one person got hit by 1 brick, one person got hit by 2 bricks, one person got hit by 1 brick. So like it could be also like that.
Imagine if you're the one person who got hit by all 6 of the bricks.
He would be having serious collateral damage.
They would.
That no one else would help him. He just lies there with all his bones broken. Everyone else is like, run away, run away.
What if it hit the ninja star? Would the ninja star like stab into him?
Well, they hit someone. They didn't hit like the ninja star, you know.
That would be called serious physical just death. Just call it death.
Yeah,
Okay.
also,
I'm gonna explain this now. So I'm gonna walk through the process. So there are 6 bricks, which you can think as the coins. And then you want to throw them at the 5 attackers, which are like your friends, but not actually friends because they're trying to kill you. So if there's 6 bricks, right? So 1, 2, 3, 4, 5, 6. So that means you would need 4 sticks to like divide them between the 5 people. So 4 sticks. And so that would mean that in total you have 10 objects, and then you have, so that means you do 10 objects, choose, and then you can choose like 4 positions for the 4 sticks. So that would be 10 choose 4, and then the answer would be your answer. You could also do 10 choose 6 because that's actually the same thing as 10 choose 4. If you remember what we like taught the other time, like if these last 2 numbers add up to like the first number, then they're equal, right? So actually 10 choose 4 or 10 choose 6, both of those are equal and they're both right. So 10 choose 4 is that's 210. So that means there are 210 ways you could have thrown 6 bricks at 5 attackers. So yay. So wait, are there any questions? Because I think some people might have been a little bit confused. If you have questions, you should ask.
Yep, we're here to learn. And questions are good.
how come the first ninja just has like 1 stick?
1 stick?
Like,
Because that's their
Very
specialization.
characteristic.
and he's like only holding it in 1 hand. Like,
That's just what they do, you know.
That's
Nice.
a really bad pun because there's sticks over here and there's a stick in that guy's hand.
he took one of the sticks to defend himself.
That means
Okay.
there's only 3 sticks then.
All right. So let's see. Okay. Oh, Yolanda, you just oops.
All right. So did your brick throwing pay off? Unfortunately, it doesn't because all of your attackers are still attacking you. So you managed to scoop up 4 more bricks while running down the hallway, and somehow they don't catch up because they're that slow. So instead, you decide to change up your strategy, and you're gonna just attack the 2 ninjas that are the closest to you. This time again, all of your bricks hit someone. It could be like, yeah, all of your bricks hit someone. Ouch. How many ways could this have happened? So give this a try on your own. Same strategy, but a little bit of a different scenario.
So are the ninjas just immortal people with physical challenges?
We shall see.
You're gonna find out.
They just have like weapons that they can guard themselves with, except for the last guy. He's just dancing. But
Yeah, they're
They're
disguised as
just
children to make you not want to, like, hurt them.
so you said
If
they
you're
were
training, you can
they
resist.
you guys said that they were your friends, right?
No, they're not your friends.
Well, that's what I heard. Well, they're seriously homicidal.
Maybe they're brainwashed by Adder.
Yeah.
Adder is a snake. If it bites you, you're dead. So
Then don't get bitten by Adder.
Okay. Attack number 2. How does our attack number 2 go? So we have 2 attackers. That means we would need 1 stick to divide the 2 attackers. And then 1 stick plus our 4 bricks. That is 5 total objects. So we would do 5, choose 1, or 5, choose 4. Either way, 5, choose 1, 5, choose 4, they equal 5. So that's 5 possible ways we could hit these 2 people with bricks. But how does it actually go? Okay.
it hits nobody.
It hits one. No, one of your attackers got knocked out.
Should we skip attack number 3?
No, I think we need to do attack number 3.
Okay.
See, this guy got knocked out.
hey, what if
We hit the
knocked out?
poor innocent guy without any weapons who was doing
KO.
Okay, you pick up 4 bricks, right? And you aim for the 3 closest people. And this time, all your bricks hit someone as usual because you are such an expert brick thrower. So how many ways could this have happened? And trust me, attack number 3 is going to be so satisfying for the most part.
Everyone
It's
gets
a
knocked out.
warehouse. It's an abandoned warehouse. Dude, I don't think the warehouses have a kitchen. Or even if it did, I don't think it had a knife in it.
There's a secret kitchen in the basement.
Why didn't you tell us that earlier? We could have gone down there instead.
So wait, you have bricks. Why don't you just go close to the ninjas and start bashing their heads with them?
Wait, can you
Because
just
one of them has a sharp pokey thingy.
Boogie thingy.
Okay, just solve the problem, guys.
wait?
Time is ticking.
Shouldn't we just take our
And
shoes?
ninjas are
Because
catching
we
up.
are a very good soccer player. They should have very good, sharp metal cleats and murder somebody.
Oh, are you wearing? I don't know. Are
I
you
just,
wearing cleats?
maybe.
Well, in that case, that would go for it. But like in this situation, you're not wearing cleats. You're wearing like heavy duty boots.
Wait, but those would still work.
Oh,
Yeah,
sports.
because they're heavy.
You're wearing slippers.
You're
Okay.
wearing slippers running through a warehouse.
Yeah.
Imagine.
No, is anyone throwing bricks? We need people to throw bricks.
Yeah.
Bad.
Come on.
The math.
Solve the problem. Okay, I'm seeing some answers. So let's see if you guys are right. So there's 4 bricks. 1, 2, 3, 4. And there's 3 people, which means that you need 2 sticks to divide up the bricks, which means that there's 6 objects total, bricks plus sticks. And then you're choosing 2 positions for the sticks, or choose 4 positions for the bricks. Either way, you get 6, choose 2, 6 times 5 divided by 2 times 1. And that is 15. So you guys are right. So there are 15 ways for you to throw 4 bricks at 3 people. So Now, what actually happened? So this is what happened. So all of your bricks hit the same person, so you knock them out. Then one of the bricks bounced off that guy and hit another person, which knocked them out too. So good job. That was like a really great attack. So,
That just sounded so satisfying.
that was like
Yeah,
a really
Are bricks
Yeah.
really that
That
bouncy?
just sounded so satisfying.
I think you should be asking if people's
Yeah,
heads are
but-
that bouncy.
Yeah.
Are bricks really that
I think you
bouncy?
should be asking if people's heads are that
What?
They have a secret balloon component.
Okay, Yolanda, you can continue to narrate.
All right. So you are almost out of the building now. Shouldn't there be like there's only 2 ninjas chasing you? But there's a problem. And to deal with that problem, we will need complementary counting.
Yeah. This is a problem. You don't remember which door you came through. So sad.
I know complimentary.
Wait,
Bruh.
which door?
Bruh.
Okay. So like Yolanda said, we are going to use complementary counting to figure our way out of this situation and hopefully before the 2 ninjas catch up with us. So, okay. So complementary counting is basically counting the opposite of what you're supposed to find and then subtracting it from the total to find the correct answer. And why would you ever do that? Well, sometimes finding the correct answer is harder than finding the total number of possible answers and the total number of wrong answers. So if you find the total number of possible answers, if you subtract the wrong answers from the total answers, then you get the correct answers. So for example, if the question is asking how many solid colored doors are there, well, you could count all the solid doors, or you could say, oh, there's one like non-solid colored doors. So and there's a total of 7 not total doors. So you do 7 minus 1 and that's 6.
What's the purpose of counting all 7 and then counting?
Right,
instead of-
because this isn't a good example, but but this is just illustrating the concept, not illustrating its effectiveness. But basically, in other situations, it will actually like be useful. But in this situation, obviously doing that would be kind of like dumb, unless if somebody already told you ahead of time that there's 7 doors, because then
Also-
you, yeah,
Also,
then it would be useful.
also, why are there doors in the warehouse? Isn't it just a warehouse?
I mean, they just have decoy doors. They're trying to trap you, you know?
Also, it's a warehouse, so like
It's Adder's warehouse. He can do what he wants with it.
Wait, who was the architect that designed this warehouse? Why do they put so many doors?
I
it was
don't know.
Adam.
We don't know. We're gonna have to figure it out. Okay. So here's an example of complementary counting where like you can definitely see why it's useful. So question is, if you flip 5 coins, how many ways are there to flip at least 1 head? And so if you just try to do this the normal way, you would count the ways you can flip 1 head, the ways you can flip 2 heads, the ways you can flip 3 heads, the ways you can flip 4 heads, and the ways you can flip 5 heads. And you would have to calculate each of those individually, which would be a huge pain. But instead, we can just, yeah, you would be crying after this. So instead of doing that, you can find the total number of ways to flip 5 coins and subtract the way that you can flip no heads, because that's the only like way that isn't what you're looking for. And then when you subtract them, you get the number of ways to flip at least 1 head. So let's find the total number of ways to flip 5 coins. Since each of them, there's 2 ways, there's 2 results from flipping a coin. You would do 2 times 2 times 2 times 2. I forgot how many 2s I said, but like you would do 2 to the 5th, which is 32. And then subtract the ways to flip no heads at all. That if you get no heads, that means you get all tails, which there's just one way to get all tails. So 32 minus 1 is 31. And the answer is that there's 31 ways to flip at least 1 head. And doing it with complementary counting is definitely easier than doing it the other way.
Okay. So the way you're gonna get out of the warehouse is that this is a riddle on top of the doors that you didn't see before, but in your panic you like missed it for a brief moment. But basically it says Andaloy rolls 3 6-sided dice. And how many ways can she roll a sum that is less than or equal to 16? So take a moment to solve that. And obviously you can solve it without using complementary counting, but I would strongly recommend that you use complementary counting, because if you don't use complementary counting, I think it's going to take you like a really long time. So just as a reminder, find the total and then minus the opposite of what you're trying to find.
So what's the opposite of a sum less than or equal to 16? Think about that.
Wait, who's Andaloy and why did she write that up there?
I don't know.
Why not?
It's probably a random person's name.
No, maybe it's a clue.
I'll give you guys 20 more seconds to solve it. There's not much time left. You guys have 5 seconds. Okay, time to explain. So the total number of ways you can roll 3 6-sided dice. So like for the first roll, you have 6 possible ways to roll. Second, you have 6 possible ways. And for the third one, you have 6 possible ways. So total, there's 216 ways to roll. That was pretty easy. Now, the opposite of rolling less than or equal to 16 is actually rolling greater than 16. So greater than 16. So the only way to roll greater than 16 is to roll a sum of 17 or 18. So how many ways can you roll an 18? Well, the only way is to roll a 6 and then a 6 and then a 6. So that's one way to roll an 18. And then for a 17, there's 3 ways to roll, because you could roll 5, 6, 6, or you could roll 6, 5, 6, or you could roll a 6 and a 6 and then a 5. There's 3 ways here. So in total, the opposite ways are 4 opposite ways. So therefore, the total number of ways to roll less than or equal to 16 is 212. So you guys who answered in the chat are correct. And if you weren't able to solve it during that time, that's okay, just as long as you are able to try and understand complementary counting.
212. What does this mean? Let's look at the numbers on the doors again.
Which one do you guys think is right? Unfortunately, 212 is not on the doors, so.
How can we change 212 to maybe match one of these things?
But add all the digits in 212.
All right, 2 plus 1 plus 2 is 5. So we gotta hurry because the ninjas almost are about to get us. Let's go through the door marked 5.
Imagine it was 8.
I was thinking that if it was one of the factors of 212,
that's also a good idea.
For my calculator and seeing, bruh.
But you guys escaped.
Right
I was thinking so hard.
You're so rare, the man.
So yes, you guys chose the correct door.
Wait, what happens after you escape? Do you capture the dude?
Yeah,
Or
the
like
Well,
Silently ambushed them after
here's
they
Yeah, but we
entered.
only escaped the
the
building.
problem.
yeah, the
I want a more satisfactory ending.
So here's the thing. You're going back to the headquarters, and then you remember that you were actually supposed to figure out who's Adder's next victim was so you could protect them. Whoops.
Yeah,
Because
they
you
died.
didn't do that.
They died in the next 45 seconds and no one knows about it.
Then as you walk back, you're worried that your boss, who's Agent Ishani, is gonna say when she finds out that you've actually failed your mission, because you like never failed a mission. You've also never done a mission before, so well so you also wonder, how did Adder know that you were coming to the warehouse? Because that's actually kind of like suspicious, right?
He's a
Like, how did
diviner.
he know?
He's a diviner. He knows the future.
But then you realize that maybe you guys, the agent, was Adder's next victim, right? Because you got attacked by Adder's like minions, and then you were ambushed.
Maybe
So maybe you
maybe-
actually protected yourself, and therefore you didn't fail the mission, right?
I think Adder is yourself after you got brainwashed.
No, actually,
Well, see, here's the thing. You guys can get to vote on who you think Adder is. And there is an option. If you believe that Adder is yourself, you could vote for that. But
so we
vote.
had some kind of like hallucination or like some kind of like manic episode, and then we wrote all these clues to ourselves.
No, then you wake up.
your adder,
No,
your adder.
no, then your mom calls you for dinner and you're like, oh wait, I've been sleeping all this time.